subtraction. We've talked about it a little bit. It's been our topic this week. So your title is What is Subtraction and what does it look like on a number line? Go ahead and write that as our title on the next blank page, please. What is subtraction and what does it look like on a number line? Right, can someone remind me, what is subtraction measuring? What am I trying to find with subtraction? Jaden?
You mean like, do you need the, what do you mean by that?
It's tricky, isn't it? When I'm subtracting, I think a lot of us think that we're just taking something away, right?
Yes.
But subtraction, we've learned, is a little bit more than just taking something away.
All the things about subtraction.
So let's think about it in terms of a number line. What is subtraction measuring, Gwen? The distance between the numbers. Tell your neighbor what subtraction is measuring.
The distance between the numbers.
Tell your paper in forms of writing on a number line. Subtraction shows the distance between numbers on a number line. The other day, Braden and I were talking about this word distance, and I told him that a lot of the time I might say distance just because to me, when I'm looking at how far away numbers are, I would say that that's a distance. However, the correct term, the correct math term, is not distance. It is difference. That's a tricky math word because we actually use difference in regular talking, right? If I have you explain the difference between Jacob and Bladen, you're going to tell me ways that they're different. That's not exactly the same thing in math. And sometimes that's hard to remember. Sean? No. You'll be all right right now. So when I am subtracting, I'm trying to find out what was the distance or difference between those numbers. If I relate it to takeaway, let's say I have 7 things and I take away 3 of them. 7 pencils, I take away 3 of them. I'm still finding out the difference between what I had and what I have left. That's still a difference. It's just a little bit different, for lack of a better word. The distance between 7 and 3.
Oh, I get it. So if you add 3,
a lot of you, and you've probably already learned this, know that you can use addition to subtract. We talked about that. It is very similar to part whole in the fact that we would say addition and subtraction are inversely related. They are opposites, if you will. Exactly like multiplication and division. Multiplication and division are inversely related. They're opposites. Addition and subtraction have the same relationship. So if I think about this, Bladen, with that part whole mindset, the whole minus 1 part equals my other part, I can rearrange that to be an addition problem. Okay. Alright, so we've talked a lot about this idea being a distance or difference between two numbers. So let's look at using a number line to subtract. And some of us are already thinking about this. Go ahead and write that equation. It says 345 subtract 234 equals box, or question mark, happy face. It doesn't really matter. It's all just a spot saver. Well, I said your question mark could be whatever you want. It could be box. It could be smiley face. It could be blank. It's just a spot saver for a number. Which of those numbers is my whole? Which of those numbers is my whole or my total amount? Emily, you with me? Okay. Yeah, Harper. 345. Now, when we did addition on the number line, we got to pick which number we wanted to start with. Is that going to be the case for subtraction? No. No. And think about it. That makes sense. If I'm subtracting something, I want to start with all my things. Right? If I'm trying to give away cupcakes, I should probably start with all the cupcakes. I don't want to start with one.
Because then you would have to go right back to the store.
Exactly. Shelby? Because if we think about them on a number line, those are different numbers. Does that make sense? Were you thinking about this? Right? Instead of regrouping, why can't I just say 5 minus 0? Is that what you're asking me? Yeah. Is that what I'm subtracting now? So let's look at it visually. This is why I don't like this way. Because we end up with questions like that. Like, come on, why can't we just do that? That makes sense, kind of. So let's look at what it looks like. And that might help us figure out why we can't do that, okay? Let's draw a number line.
It's funny how a single question changed the whole thing.
Hasn't changed anything. Been doing this long enough, I know what questions you're going to ask me, probably before you ask me them. I know, it's weird. A couple of you keep me on my toes. Some of you ask questions I didn't see coming. Like yesterday's question I did not see coming. It's fine. The compensation strategy. I know my whole. 345. That's all my things. That is all my puppies. That is all my cupcakes. That is all my pencils. It's all my whatever. Where is that going to go on my number line? Where is that going to go on my number line, Michael?
At the beginning or end.
Is it going to go at the beginning?
No.
Or is it going to go at the end? Gonna go at the end. If we think about my number line, the largest number is always going to be towards the right. I'm not getting any bigger than that. That's all the things I got. I'm not getting any more of them.
What's your other?
I'm going to make my ending number line 0. Because remember, my whole is all the numbers 0 to 345. All those numbers in between. Does that make sense so far? So sometimes zeros start to look like the letter O. So I try to make sure that we know that it's a 0 by putting a slash through it. Just like I do 7s, exactly. Bladen, yes?
So I don't know if
we are going to subtract backwards. That is exactly what we're going to do today.
If you have 345 and 234, you go by 5. Isn't that 340 now?
Yep, we are going to be mixing up our counting backwards strategy that we talked about yesterday. Yep. And our number line. going to be, I don't, sometimes my marker forgets what color I'm writing in, so weird thing.
That's actually kind of cool.
It's weird. Alright, so can I just do one big jump of 234?
No. Yeah, but it was,
Technically, yes, but I don't know what that is. So I'm going to break it into smaller chunks. What should I jump by first? I'm going to break that 234 into smaller chunks. Lincoln, what do you think?
also like 200.
You want to do 200? Where did 200 come from?
The 234.
Yeah, I broke this, and I know there's 200. I know there's a 30, and I know there's a 4. So far, so good? We're going to go backwards. This is sometimes tricky for 3rd graders because we're used to going forwards.
Yeah, this is tricky for me.
What is 200 before 345?
Oh.
You can do it. We do this in our digit game. 345 subtract 200.
Oh, yeah.
Think about what place value you're playing in. Jacob, what do you got it? No? Still thinking? Elena? 145. Harper, what place value did I change? The hundreds, because I was subtracting hundreds. So I've done my 200.
Now we need the 30.
You want to do 30?
Yes.
Do you want to do one big jump of 30?
Yeah.
Sure. Could I do smaller chunks?
Yeah, like 25. You can do like, or 20.
Whatever you want.
20 and 25.
I like to do one big jump when I know that I'm not going to have to regroup, which means that right now I have enough tens that I can just simply count backwards. 4 tens minus 3 tens. How many tens do I have now, or what is my ending number?
Kind of like
7? 115. Very good. All right, now I've got 4. Can I just do a jump of 4?
Yeah. Or you can just do a 1. Because you can count on that easily.
What's my new ending number? Ashlyn? You count backwards. Bladen, you got it?
179.
No, we're not 179. No, you're right. 115. That's where we are. Now go
I
backwards.
was adding this.
I noticed. That's all right. You're right.
And it's 119.
Backwards.
Oh,
111. There you go. 111. Now, this section is my other part. 0 to 111. That's 111. 111 to 345 is my 234. And then my whole is 345. So I know, Bladen, you were saying that this looks like part whole. It should look like this.
Wait, so it equals 1. Oh.
Do you see that on a number line?
Yes.
Do you see the big section? The reason why we like to draw a bar model is because that's a gigantic number line.
Yeah.
It's got 345 numbers on it. That's a lot. It's a lot to start to imagine. So when we subtract, we like to use our bar model down here because that makes it a little easier to look at. But we can see the part and the other part and the whole thing. look at this problem. There's no numbers in it. Let's just think about what it's asking. There are some third graders. There are some number fewer second graders than third graders. How many second graders are there? What's happening in this problem? What's happening in this problem? What is happening? Well, what's happening?
They're they're comparing how many second graders are to third graders.
Love that. I love that you said comparing. That is exactly what we're doing. Third grade versus second grade. Yeah, we got third grade versus second grade. We know there's some third graders and we know there's some second graders. Who has more?
You don't know that because there's no number.
Oh, I might know that though. Look at that problem again. I don't know exactly how much more, but I bet I can figure out which one has more.
Third graders and they say that second grade has fewer.
Second grade has fewer. So I already know that third grade's going to have more than second grade. I don't know how much because there's no numbers. But I do know there's going to be more. What should eat left? Yes. Alright, let's put in some numbers, see what happens. There are 166 third graders. There are 19 fewer second graders than third graders. How many second graders are there? What am I counting in this problem? It's not a trick question. What am I counting in this problem? What is my unit? What am I counting? Go and stop coloring pictures, please. Oh, I know, what am I counting?
Third graders.
Nope, I am not counting third graders. Look at that question. It is asking me, how many second graders are there? That means I must be counting second graders. If I am writing, you are writing. There are blank second graders.
You need to find a different page.
Sure.
I have an idea
What's your idea?
about whenever you want to start something, you write it on there. When you don't want to start something, you write it on the way. There's a bug.
Nope, nope. We normally would draw some kind of model. But we'll notice something important about this problem. Nope. We are comparing, so it's going to look a little different. Nice. Because we're comparing, our bar model is going to look a little different.
Okay.
All right? So we know that we're comparing what, Will?
Second graders to third graders.
Second graders to third graders. Let's draw a bar. This is my third grader bar. I'm going to write a 3 next to it. Actually, a third next to it. So I know that's my third graders.
Alright.
Do I know how many third graders there are?
No.
Yes, I do. There's 166. So inside that bar, I'm going to write 166 because that bar now shows how many third graders I have.
So we could probably be
Hang on to that thought, Devin. Is my bar for second graders going to be bigger, smaller, or the exact same? It's going to be bigger, smaller, or the exact same? Asha, what do you think? Why do you think smaller?
Is that 19 fewer second graders and third graders?
Yeah, we already talked about how there's going to be less. We didn't know how much less a second ago, but we saw that word fewer, so we knew there's less second graders. Let's make, because 19 is not a big number, Let's make a slightly smaller bar. Like that big.
Like almost halfway.
Sure.
Are we allowed to put ours in the middle?
Yellow.
What does that mean?
Do whatever makes your brain happy, love. Thanks.
Yay!
I'm gonna label that bar with a second.
That was a blow.
But I don't know how many second graders. Henley, please get that off your head. So I'm gonna put a question mark. I don't know.
Oh.
Just question mark is fine. But there was one thing I did know. Harper, do you think
There are
you're
19 fewer.
this space right here is 19. How did you know that, Harper? That was awesome.
Because it says there are 19 fewer second graders than third graders.
So I know that the second graders, plus if they had those imaginary 19 more kids, they would have the exact same amount as third graders.
So we need to minus.
So how am I going to figure out the question mark?
We're probably going to do subtraction. You're going to use your brain.
Does anyone have an equation that you think it might be? Gwen, what do you think?
166 minus 19, and that would get us the answer.
Hey, does that look like part whole?
Yeah.
It's like a weird part whole, isn't it, Bladen?
Yeah.
Do you see it?
Yeah.
Where's the hole?
Oh, the 166.
Uh-huh. Where are my parts?
The 19 and the number we don't know yet.
It's just, I want you to solve this on a number line. Go ahead and try it in your notebook.
I'll try.
Try it in your notebook. If you get stuck, look at the one we just did. Try to count backwards on our number line. Let's look at what many of you did. I saw a lot of you start with a number line, and then you put 166 on that number line. Where did you put it?
Very end. Oh.
Where did you put it? Show me where you put it. The end. Why did you put it at the end? Yeah, that's my biggest number. I'm not getting any bigger. I'm not getting any more students. Right? 166. I'm going to start going backwards. I saw many of you go backwards by 10 first. Why did you do that? I saw many of you go backwards by 10. Michael, why did you do that?
Because 10 is easy to subtract with and to add with.
Yeah, we can definitely go forwards and backwards by 10. What number did you end up with? 156. Now, some of you from here did something very interesting. Give me a make two signal if you went back to 9 from here. Like one big jump of 9. A couple of you? No, a couple of you did this. You said 156. Subtracting 9 is going to be tricky. I'm going to subtract by 6 and get me to a friendly number. So now I'm at 150.
Yeah, it's 6.
But then 6 is not 9. I have 3 more to go. So I went another 3. Now what number am I at?
147.
147.
And you didn't even have to need that much space.
I didn't need that much space. How many second graders are there? How many second graders are there, Sean? How many second graders are there?
138.
Nope.
Oh, 48.
Nope.
147.
147.